Hey you guys, Lissandra here, and today I'm going to do another whiteboard tutorial. And today I'm going to be talking about a particular interesting topic. Even though I don't have no particular um, preference for to do this as a career, but as far as hobbies and everything, as far as like I guess a primordial part of software development. I do have interest in it, and it's called uh, cryptology. Okay, now the word crypto is a Greek word, which is usually means hidden or secret. Okay, and logy, that's relative to logic, which means which is also relative to knowledge. Knowledge. Okay. Now, is the pretty much means knowledge of the hidden, or knowledge of secrets, of keeping secrets, and basically is it has to do with algorithms. It has to do with encryptions, that sort of thing. Have you ever gone to a website that um, I'm sure you've probably seen this, HTTPS, and then this S is it means it's a protected site, and it usually has encryptions. Or if you see SSL encryption, there's a bunch of them. There's RSA, there's SHA 0, 1, 2, and I think they have 3. I'm not really sure. Okay, all these they're encryptions, and and the reason why they want this is that it's pretty much keep things confidential between two people. Now, can you imagine if everything you said was completely entirely known to everyone openly? Of course, um, of course, privacy mm, is always a concern. Now, as far as cryptology goes, cryptology is the study of both of decrypting and encrypting ciphers. Somebody that studies studies how to decrypt is a cryptoanalyst. A cryptoanalyst. That's what he does. He's focused on decrypting already encrypted uh, ciphers. Now, the opposite of that is someone who encrypts, and that's a cryptographer. A cryptographer. Okay, and you can tell which one is which. Crypto analyst, he analyzes. Why? To decrypt it. That's his job. In uh, encrypts, cryptographer. He grabs the symbols. He encrypts uh, the ciphers. Okay. So now that we got that out of the way, one of the first encryptions that there were relatively simple. For example, um, think of think of it this way. Think of it as, let's say you have an army of people. Okay, you have your let's say you have your sword and everything. And the thing is that, let's say you have a tower here that's relatively high, or is somewhere hidden in pretty much hidden in the bushes somewhere. Okay, let's say somebody is, and this, I guess, let's ignore this for a sec. Okay, let's say somebody is hidden in the bushes. Okay, and this person pretty much is trying to ambush this guy, or let's say an army of people that are following him. Okay, and what does he do? He wants to alert the people, but this guy doesn't want them to find out. And the people that they're going to, let's say this is a road all the way over here, all the way to whatever tower this is or whatever place, and there's people here. Okay, there's people here. So what would he do? One way of doing it is pretty much a mirror. Shine a mirror that can be reflected from a distance, and it notifies this one. That's a very simple way of a cipher. But the thing is, as time progressed, things got more complicated. Okay, so around the time of the Roman Empire, there was a cipher that went by the name of Caesar cipher. I'm spelling it wrong. Caesar cipher. And basically, what this read is pretty much it went like this. Okay, it went like this. Suppose you have your basic alphabet: A, B, C, D, E, F, and so on, all the way to X, Y, Z. Okay, so let's say you wanted to send a message to someone, but you don't want your enemy to find out um, what the message is. So basically, person A, person A, which is the person receiving the message, got a message from person B. And the thing is that what he wanted to do, what person B wanted to do was encrypt. Okay, encrypt. And person B wanted to decrypt. And and that's very important. That way, there isn't a person C trying to intercept any of the messages being sent. Probably this one could be a spy or whatever other type of person there is out there. Okay, but the way this type of encryption work, Caesar cipher, is that pretty much what happened is that since you have A, B, C, D, E, F, uh, what you did was that you shifted, and this shift was only shared between the person receiving the message, which is person A and the person sending the message, person B. So let's say you have one shift, okay? So you would start out right here, A, B, C, D, E, and so on. It'll continue on, okay? And up until the point that you get here, X, okay, W, X, Y, and Z would be over here, okay? So let me go ahead and erase this, okay? So the way this worked is this. Let's say you wanted to encrypt the word, uh, let's say you wanted to encrypt the word car, okay? Okay, so you have a one shift. So so you start with the letter C. You shift it over one. Um, in contrast to over here, of, of course. Okay, so C. Okay, so instead of C, we will put B. Okay, it all depends which direction you're shifting in. It could be shifted left or shifted right, but it was a one shift. You just had to specify which direction you were shifting. Okay, so let's say for this occasion we're shifting it from to the right. So one R. Okay, okay. So uh, C A A would be Z and R. So R would be Q. So BZQ is a one shift right encryption for car. Okay, so this one's decrypted, this one's encrypted. Okay, now the encryption is very important in nowadays, especially network security. When you have a whole setup of systems which connect wirelessly, encryption is a must because people can take advantage of it. And consider this: if we already have identity theft, considering a high level of encryption we have, um, how much easier do you think it would be for people to swipe your identity? Uh, Considering you had no security, it's something that we take for granted, and it's seamless. We don't notice it at all. As a matter of fact, there are already messengers that are encrypted, that you encrypt messages, and there's a whole variety of algorithms of encryption, whether encrypting files, sizes, and all. Uh, there's uh, there's blowfish encryption. There's whirlpool. There's SHA, which is 0, 1, and I think 2. Okay, and then there's AES, SSL, and so on. All these type of encryptions. But this is only a little introductory of what cryptology is and all. I'll cover more in depth of this sort of stuff on my next video of this series. For now, thank you for watching. Please like and subscribe, and I will catch you guys later.